Hey everybody, welcome to week 8, audio coding with SuperCollider. We're going to get started on top of the hour like we usually do. So just a couple minutes, get comfy, grab a snack. Hey Joshua, good to see you. Hey Jarvis, good to see you too. Welcome. Hey Nicola. Hey Caleb. Hey Seaborch. Hey Jessica, welcome. Cool. All right, 3 o'clock. Welcome again everybody, let's get started. Before we dive back into buffers and sampling and audio files, I want to review one question that was on homework 5. It was sort of the last set of questions. A lot of people got this wrong, or just got a small part of it wrong. So I just want to go over it. So let's boot the server. This was a problem which gave you a function which, when played, produced 16 pulse waves with unique frequencies, all rounded to the nearest multiple of 50, and spread across a stereo field. So it sounds like this. And for these problems, I'm just going to focus on this one. The rest of them are kind of similar. Problem 7 asks you to modify the code using principles of multi-channel expansion so that the amplitude of each of the 16 pulse waves drifts between 0 and 1 slowly, randomly, and uniquely. Now, pretty much everyone got the multi-channel expansion part of this correct. Most people made a new variable and set it equal to an array filled with 16 noise generators. And I've left this empty here on purpose. We're going to get back to that in just a second. And then you either plug it in like this by just sig equals sig times amp, or you can plug it in for the mul value here. Either way is fine. That's the essence of it. What people got wrong is the range issue. Most people gave me an amplitude modulator that ranged between something that wasn't 0 and 1. So I want to just refresh all of our memories on the idea of specifying the output range of unit generators and the idea of mul and add and how they're used to accomplish this, as well as the range method. So I left some comments in everybody's homework. So for example, let's look at, I'm going to plot 3 noise generators. They all have the same frequency, 500 random values per second, but they have different mul values. So what most people did here was you gave me a frequency which was sufficiently slow. That's one of the key words here, a slow moving noise generator. So a low frequency, something like 1 or 2, or something between 0 and 1, those are all fine. And then what a lot of people did was, for the mul value, gave me something like this, where the mul was a random value between 0 and 1. Now this does not have the effect of causing the UGen's output to be between 0 and 1. Instead, it has the effect of scaling the signal around the horizontal axis. And so to demonstrate that, here's 3 noise generators with 3 different mul values. So it's 500 values per second. We're just looking at a small slice of time. The one on the top has a mul value of 1. So its output range, this value here at the top is 5. This is -5. You can see it's got a default range of -1 to 1. So all of the values it chooses are in there somewhere. This one's got a mul of 0.2. So it's been scaled down by a factor of 5. And this one on the bottom has a mul of 5, so it's been scaled up by a factor of 5. The highest value this one could generate is 5. The lowest one is -5, or most of the time somewhere in between. So that's how mul works. So if you provide this for mul, then you're going to get some bipolar noise generator that goes between negative and positive some value in this range, which is not the same thing as producing a signal with an output range of 0 to 1. So we can use mul in combination with add to achieve the desired range. So here's a quick example of how mul is working. So if we plot these, sorry, add, not mul. Is that working? There we go. Okay. So here on the top, we've left add at its default value of 0, which means we have our default range from -1 to 1 with no value added to it. And here, the second one here, add is 1, which means it started out with a value of -1 to +1, and a value of 1 has been added to every sample in that signal. So the resulting range is 0 to 2. And here the add value is -2, so it goes down by 2, so the resulting range is -3 to -1. And that's how mul and add works. So we can use mul and add to achieve the desired output range here. So if you want to use mul and add, you can say 0.5 for mul and 0.5 for add. Now, these identifiers here are not technically necessary because mul and add are the only two remaining arguments, but it doesn't hurt to put them there either. So by specifying mul at 0.5, this takes the nominal range of -1 to +1, shrinks it by half, so it goes from -0.5 to +0.5. Then we add 0.5, which shifts that range up so that it's between 0 and 1. So this would be the correct result, and it would sound like this. And if you listen, you can hear individual frequencies are sort of fading in and fading out. That's the idea. Now, I personally find mul and add to be kind of cumbersome if you want to specify a range, because you have to kind of do a little bit of the math in your head. So for that reason, there's a method defined for unit generators called range, which allows us to just specify the range we want. So this is an alternative way of doing the same thing. So it kind of depends what you like to do. I think this is kind of obviously the easier one. It's more typing, but it's less work. Just be sure that you don't specify mul and add and also specify range. These are two options for doing the same thing, so you should use one or the other, but not both. So I think that's all I have to say about that. So hopefully this makes sense. Specifying the output range of unit generators is a very common thing to do, especially when one unit generator is controlling some aspect of another. So mul and add, be aware of how they work, and also be aware of the existence of this range method, which is kind of a convenience. All right, back to buffers. So we're going to pick up where we left off. I've got my folder, which I've renamed week 8. It's got the code file in here, as well as a subfolder of audio. I've added this wow file to our motorcycle and 2 numbers. So we've already got the server booted. And if you remember from last time, this line of code is a clever little trick that relies on this process.now executing path to generate a path to the audio folder in your project folder. Excuse me. So that this path is always accurate no matter where it is or what computer it's on. So if I send you this folder, you can just run this line and it will give you the correct absolute path to wherever you stored your project folder. And then we just use that path to read in these 4 files. So we'll command enter on that. And then we started working our way through a simple ugen function, just function.play. So just as a reminder, we've got the number of channels, the buff num for the buffer we want to play. We use buffer rate scale to ensure that the playback rate, to compensate the playback rate if the buffer and the server have different sampling rates. And not pictured here, we also had trigger, which we'll just set to 1. Start position in frames, we'll set that to 0. And whether we want it to loop, we'll say 0. And then a done action. Because when playbuff gets to the end, if loop is 0, or if, in other words, if loop is disabled, playbuff checks its done action. And then we just scale down the amplitude because playbuff doesn't actually have an amplitude or a mull argument. So it sounds like this. We also had our number file,
2, 1, 1, 0.
which is a 1-channel file, which is why I've changed this 1. And then we also have wow, which sounds like this.
Wow, sound editing just gets easier and easier.
Right. Okay. So what I'd like to do today is transition from function.play into SynthDefs. Because if you remember with synth and SynthDef, it's kind of the more formal and flexible way of defining a blueprint for a sound. Function.play is kind of a quick and dirty way of doing it. So let's go ahead and make a SynthDef. And let's see, we're going to say, we'll call this PBB, play buff. And we say var_sig. I mean, we could even just copy most of this in here. Oh yeah, this will be available after. Most definitely. So SynthDef needs a name, which we've given it here. It needs an out ugen. And we need to add it to the server. Now we're going to change a bunch of stuff here. As you can see right now, these are kind of hardwired into the SynthDef. We're saying play this specific buffer and use this specific buffer to adjust the rate. Thank you. Thank you, thank you, thank you. Sorry. Always so easy to overlook that. Thanks, Seaborch. Appreciate it. So SynthDef looks like this, but if we leave it, I mean, this will run just fine. It's going to complain about that out argument. But the problem with this SynthDef is that it's always going to play this buffer. It's always going to have loop 0. It's always going to have done action 2. This amplitude is fixed at 0.3. So SynthDefs become more powerful when you add arguments. So we want to add lots of arguments here. In particular, we want to add an argument for which buffer we want to play. And we'll default that to 0. So this way, when we actually call the synth, we can say, oh, and by the way, use this sound file, or maybe use that sound file, rather than sort of permanently baking in wow.buffnum in here. And so similarly, for buffer rate scale, we'll compensate based on the buffer that we're playing. We're going to take its buffnum and get its sample rate and compensate with the server sampling rate. And we're going to multiply this by rate, because we want to be able to provide a playback rate in case we want to speed it up or slow it down. Now here, we go ahead and add some arguments here. So we have our trigger argument, preceding it with a T underscore to make it a trigger type control. I just SPOS for start position, loop, and we can even make an argument for done action as well. And it's always good to make arguments, not just making arguments, but also giving them sensible default values. So we'll initialize the trigger at a value of 1, so it immediately jumps to the start position. I think a sensible starting value for the start position is frame 0. Why not start at the beginning of the sound file? And loop, I suppose we'll initialize that to 0. Don't loop by default. And the done action for the play buff will be 2. And I think it's always a good idea to make an argument for the output bus. Even if we're just sending it to speakers and it's always going to be 0, it definitely doesn't hurt to have some of these declared, so really all of them declared as arguments. I'm going to set amp to 0.5 just so it's not full amplitude right out of the gate. And this should be good. No, it's not. What did I do wrong? Buffnum not understood. Yeah, I think we need to get rid of this. We can't say buffnum to an argument because it's not actually a buffer anymore. It's an argument, which turns it into a type of unit generator. So I think that's the problem. My mistake. All right, so now that we've made a SynthDef, no problems or anything, we can just simply call a synth. And assuming we've given our arguments sensible default values, we should just be able to play it. And we can. All right, I'm just going to command period on that. Now I played the motorcycle sample. Even though we didn't tell it to play any particular sample, that's because buff is initialized at 0, and motorcycle is the very first sample we loaded. So moto has buff num 0, and num, buff num 1, etc. Now, if we wanted to specify a particular buffer, we've seen this syntax before. We synth.new, we give it the name of the SynthDef we want to use, open up an argument array, and we say buff, comma, we can say moto. This would be fine. Command period, num.
2, 1, 1, 0.
Or wow.
Wow, sound editing just gets easier and easier.
And so we have a little warning. It's a very soft warning in the post window. Buffer ugen channel mismatch. Expected 2, yet buffer has 1 channel. And that happened when we played this one.
2, 1, 1, 0.
So num has 1 channel. This particular sound file is monophonic, but we have put a 2 here. Now it might be very tempting to do something like this. Make an argument, right? We'll set it equal to 2 by default. And now if we run this, we get a big old error message that says error non-Boolean in test. A Boolean being a true or false. And it's expecting some sort of Boolean value, and all we did was add an argument and plug it in. This is not allowed. And I'm going to try to explain why without going into too much detail, because it's kind of a subtle concept. The size of the size of signals, the sort of multi-channel size of signals on the server has to be fixed at runtime. Or in other words, you can't dynamically modulate the number of channels in a signal. You can't say make it a 2-channel and then smoothly interpolate from 2-channel to 8-channel to 16-channel to 174-channel. You just can't do it. You have to declare upfront this channel has size blah, a number, a fixed number. And this seems like we are doing this, right? We're saying arg enchan equals the integer 2, and then we plug it in here. So it should be fine, but the problem is that once we declare an argument in a SynthDef, enchan is not actually an integer anymore. It's an instance of a unit generator called control, which is a type of unit generator that is created automatically for us when we declare arguments inside of a SynthDef. Controls are created from the arguments of a SynthDef function. And so what SuperCollider is doing is it's trying to sort of multi-channel expand using a unit generator as the number of times to copy the thing. And so this also doesn't work if we make like a really simple SynthDef, something like, see if I can make this real quick. And we just say arg nch for number of channels. We could put an out. It doesn't even matter if we put an out here because it's not going to work. So if we do this, all seems pretty harmless. We're going to say number of channels equals 2, and we're going to multi-channel expand this sign-off by making 2 of them. But again, it doesn't work. We get a slightly different error message. Primitive basic new failed. Index not an integer. It's talking about this thing. It's trying to say, duplicate this many times. And we're like, oh, come on, what's the problem? It's 2. Make 2 of them. But this is not actually the number 2. It's a unit generator that by default spits out the number 2 at the control rate. So it's roughly equivalent to saying something like this, which is utter nonsense. This NCH is a type of unit generator. So we're saying, take this and make an array of copies and make this many of them. And it's like, that's a unit generator. It's a dynamic value that could change at any time. So it's not allowed. And so for that reason, we need this to be a fixed value. Now, this is kind of annoying because if you have a project and you're working with a combination of mono and stereo files, one playback SynthDef is not going to accommodate all buffers. So realistically, the right thing to do is actually make two of these. One of them, we'll call it PB1 for mono and PB2, and we just say 1 for the mono play buff SynthDef and 2 for the different stereo SynthDef. And now we can run these two together, and that should be fine. So now we go down here, and we can say PB1, PB2. If we say, I think that one's stereo. So now if we say num here, and moto, and also wow, all the errors should go away.
2 1 1 0.
Wow, sound editing just gets easier and easier.
So that's the idea. You actually, because we're dealing with two different audio files that are in two different categories based on the number of channels they have, you are going to need two SynthDefs, one for mono, one for stereo. Kind of annoying, but it's a small price to pay, I think, for a lot of other flexibilities. Now, what happens if we, kind of screw this up a little bit and we play a mono buffer with a stereo SynthDef or vice versa?
2 1 1 0.
So that one, oh, you know what? I have an issue here. Well, sort of have an issue. Yeah, I should not be multi-channel expanding here because SIG is a 2-channel play buff. So there's no need to do this. In fact, it's making an array of arrays when I do that. So that's my mistake. So here we go. So now
2 1 1 0.
we have a mono sound file, a stereo SynthDef, and it says channel mismatch. I'm expecting 2 channels, and you gave me 1. So what it does is it says, I'm going to play this 1 channel in the left, and you're not getting anything in the right. Now, if we do the other thing, play a stereo file on a mono SynthDef, again, it gives us the error. Expected 1, yet buffer has 2 channels. So it plays just one of these channels, but because we have exclam2 over here, it copies it. So if we got rid of that, then we'd only hear it in 1 channel. So what I think makes sense is for the mono one, we'll say sig equals sig exclam2. Because this is mono anyway. We could do like a pan 2 here or some other panning algorithm. I'm just going to say, just copy it. Just copy it to the other channel so we get it in both. So now everything should be working. We'll get moto. We get a nice stereo image because that is a stereo file. And then anything that's mono
2 1 1 0.
will automatically get copied to 2 channels. So we're in pretty good shape. We've got 2 healthy looking SynthDefs here. So now we can actually start playing around a little bit. And I'm going to copy wow, bring it down here. And we're going to space this out so that we have a little bit more room to work so it's not all on one long line of code. And so we can specify the buffer we want. We can also, I didn't mean to evaluate that, sorry. We can say start position. And if we set it to 0, well, it just starts at the beginning.
Wow, sound editing just gets easier and easier.
But we can specify another value in frames.
And easier, and easier, and easier.
Right? Sound editing just gets easier and easier and easier.
And easier.
And easier. Now, I'm just kind of throwing in random values here. And these are
Editing just gets easier and easier.
just sample values that... now I really have no idea off the top of my head how many frames WoW has. But we can retrieve that value when we call the synth. So WoW has 159,768 frames. Now, if we want to start halfway through, well, it's pretty easy. We can just say multiply the number of frames by 0.5.
It's easier and easier.
And we just start right halfway through the file. We can start at the final 10% of the file by multiplying by 0.9, right? So we're 90% of the way to the end.
Easier, easier, easier.
So that's good. Start position, pretty easy. If we want to loop, we can just say, when we make the synth, loop it. So if we get to the end, ignore the done action, just go straight back to the beginning. I forgot a comma at the end of 84.
Easier. Wow, sound editing just gets easier and easier. Wow, sound editing just gets easier.
Probably should have given this a name.
Easier. Wow, sound editing
free
just
it.
gets easier.
Yep. So we can turn loop on, done action gets ignored. And we can also, let's leave that on actually. Bring this back to the beginning. And rate, of course, how can we forget playback rate? So 0.5, octave down. Need a comma on line 85 as well.
Wow, sound editing just gets easier. And easier. Wow, sound editing just gets easier.
Wow, sound editing just gets easier. Wow, sound editing just gets easier and easier.
Yeah. And I have to do command period again. This, if we're making multiple synths and we want to be able to free them all together, we can't be constantly overwriting them with X. So command period, I'm just, I try to make these. Yeah, wow, totally. A lot of fun. Okay, so from here, let's reintegrate some concepts we already know. The first of which is iteration. So let's actually collect over the number 5, which is going to be equivalent to doing this. 5.collect is a shortcut for the array starting at 0, containing integers that has that many things in it. It's a nice shortcut. And we can just drop this in here. And if we run it as, oops, I need to finish those curly braces and parentheses, and then the evaluation enclosure. Now, if we do it like this, these are all going to be the same every time a synth is generated. So it's just going to be the same sound, but with 5 copies, so it'll just be louder than usual. Interesting stuff we can do here is, well, we'll give it a random playback rate. Maybe minus 0.5 to, I don't know, 1.3. So each one of these is going to pick a random value. So on the first pass, it might have that playback rate, so slower than usual, about the same, a little faster, a little slower. Right? So it'll just be 4 random values. It'll sound, let's go ahead and do amp 0.2, so it's not too loud.
Wow, sound editing just gets easier and easier. Wow, sound editing just gets easier and easier. Wow, sound editing just gets easier and easier. Wow.
We could free them like that. We don't have an envelope in our SynthDef, so there's no way to do a fade out. We could add one if we wanted to, but for now, this is a quick way to just get rid of all of them. It gets more fun, actually. I mean, that was random, but we can actually bring in an iteration counter. Remember, if we declare an argument inside of a collect or a do or any sort of iteration construction, this argument is going to represent the numbers. If we do 5.collect or 0, 1, 2, 3, 4 array.collect. So it's going to be 0, then 1, then 2, then 3, then 4. And also remember that for rate, if we don't want to think in terms of ratios, we can say an integer in semitones dot MIDI ratio, which converts it to the proper frequency ratio. So that will sound like this.
Wow, sound editing just gets easier.
Sound editing
just gets easier.
Yeah. So let's go ahead and use that as a raw value in semitones and dot MIDI ratio. So the first one's going to be normal. Next one's going to be up a semitone. Next one's going to be up 2 semitones. And they're going to be 5 altogether. And they're all going to start at the same time.
Wow.
Yeah, so they start in phase, but because they all have slightly different playback rates, they kind of drift out of phase into this very regular way. Other stuff we could do, I mean, let's just take this, and instead of n, we'll say, divide that by 10. So each one is a tenth of a semitone separated. So it sounds like this.
Wow, sound editing just gets easier and easier. 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 Wow, sound editing just gets easier and easier.
Yeah. So initially, the playback rates are so close together that we don't actually hear like a delay or an echo. We just hear like a flanging comb filtering effect because they're like separated by such a small amount. We hear this sort of resonance of all of the sound files adding up together. So we could like make even more of these. and make the difference like sort of even smaller. This might be kind of crazy.
Wow. Sound editing just gets easier and easier.
Yeah, make that a little louder.
Wow. Sound editing just
Very
gets
strong
easier
resonance.
and easier. Wow. Sound editing just gets easier and easier. Wow. Sound editing just gets easier and easier. Wow. Sound editing just gets
So lots of fun stuff to play with there. Yeah, iteration's a powerful tool. Oh yeah. You can use sounding with pbind, but it doesn't make a lot of sense. Just because you don't really need multiple sound ins, you just need one. But those are two things we have not yet seen in this class, so I don't want to go into detail there. But we will get to patterns in pbind in the next couple of weeks, and possibly sound in as well. But if you want to stick around afterwards, we could chat about that maybe. Okay, let's do routines. We talked about routines briefly. Routines are basically functions that allow you to wait, and they can be played. So what I'm gonna do here is drop this in, and yeah, this is fine. And we're gonna say don't loop. Done action should be 2. The rate, we'll do a random value here. -5 to +5. We'll convert that from semitones to a frequency ratio. And okay, so in this routine, we're going to loop. We're going to loop. And whenever we are in a loop, we must wait. We must wait. Unless we want to be very sad. This is one of the most crucial things to remember. If you are making a looping process that produces sound that loops forever, you have to wait. You absolutely have to, unless you want to crash the program on purpose. Okay, double check this. We have a routine which we are playing. Inside that routine is a loop. It plays a synth. It plays this wow sample. It starts at the beginning. It does not loop and just goes to the end, and each one's going to have a random transposition up or down, 5 semitones or somewhere in between. And amp is probably, we can make that a little higher, and we're just going to wait 1 second. So here we go.
Wow, sound editing just gets easier.
Sound
Wow,
editing just
sound
gets
editing just
easier.
gets easier.
Wow.
Wow,
Sound editing just gets easier.
Wow, sound editing just gets easier.
Wow.
Sound editing just gets easier.
And easier.
Yeah, so a little texture generator. Don't forget about choose. So let's see, we could just start this at the beginning. We'll say wow or moto, because these are both 2-channel files, .choose. And it'll plug that into the SynthDef and play whichever one it happens to pick. Let's bring this down quite a bit and wait 1/3 of a second. So it'll come a lot faster now. Yeah, so that's routine. If we wanted to pick like all 3 of these, for example, some of those motorcycles really drag on. Even though we stopped the routine, that doesn't stop the sound. It just stops the routine from generating new sounds. So I'm going to command period on that. Now if we do this, if we do this, we're going to get some of these because it might be picking num, which is a mono buffer, in which case that gets plugged into a stereo SynthDef, and then we get this, it's not a disaster, right? It doesn't blow up or anything. It doesn't crash the program, but it does flood the post window with these gentle warnings. So here, it might, if we want to modify this so that it picks all of the sound files, it might make sense to do a little conditional logic. So we actually make a variable here call it buff. It doesn't matter that it has the same name as this. It's just a local variable. And we're going to say this is buff and put that up here. So we choose buff up front, and then we say if buff.numChannels is 2. Go ahead and play the stereo version. Otherwise, play the mono version. which would be PB1. Now we've made these SynthDefs almost identical. The only difference is their name and the number of channels of the playbuff object. So this sort of takes care of that issue. Semicolon at the end of 177. And I think this should be fine. So that allows us to throw all buffers in there. It doesn't matter if they're mono or stereo. If they're stereo, it does this one. Otherwise, there's only, I know these are all mono and stereo, so there's only one other possibility. W-choose is fantastic too. Yeah, lets you just show that real quick. You provide W-choose with an array of weights. So, and these have to add up to 1. So you can say like 0.45, 0.1, 0.45. And so now there's a 45% chance of choosing wow, 45% chance of choosing num, and a 10% chance of choosing moto.
Wow.
And easier.
Very good find. Just you can hear there's only 2 motorcycles there, but like a whole bunch of wows and numbers. Now there is a kind of a cute trick here. Because we've named these SynthDefs 1 and 2, we can there's a little bit of a way to do this that doesn't involve conditional logic, but actually using the number of channels of the buffer as is. Now this is kind of cute. Some of you might like this. We're going to declare another variable called def, and this is going to be a symbol corresponding to which SynthDef we want to use. So def is going to be, it's going to start as a string, PB, and we're going to concatenate with no spaces. That's what the double plus means. It means just tag another character or a sequence of characters onto this string. Buff.numChannels.asString. Put that in parentheses just in case. So this is going to be either the integer 1 or the integer 2, which gets converted to a string. So this whole thing is going to end up being the string quote PB1 or quote PB2. And then I think we don't necessarily need to do this, but we can turn the string into a symbol, and then we just say def here. I think we can omit this because SynthDefs are perfectly happy to take strings or symbols. It treats those as being the same. So now, yeah, we don't need any conditional logic, but we'll be avoiding all of the channel mismatch errors. Yeah, so that's kind of fancy. I like that. Now, here's a question for everybody. Let's turn our attention back to our SynthDef. And the question is, what if we want to play one sort of subsection, like a tiny 1/10 of a second chunk of like the wow sound file? Instead of starting somewhere and just playing all the way through or looping around, we want to just get like, instead of wow sound editing just gets easier and easier, we want the E sound in easier, like E. That's what we want. How do we get that? How do we get that with just playbuff? And the answer is we can't really unless we change it. As is, the best we can do is pick a start position and then like cleverly free that synth like a 1/10 of a second later, which is very clumsy. So the answer is you add an amplitude envelope. So let's go ahead and do that. So we're going to make a variable called env. I'm going to rename this SynthDef, pb2env. I'm only going to bother with the stereo sound files. I'm not going to make 2 of these SynthDefs, just 1. And the env is going to be our good friend envgen. I'm going to use AR just in case we want a really, really short envelope or something like that. So it's a nice high resolution unit generator. And I'm going to do one of my classic sort of envelopes that I always rely on. I'm going to add 3 more arguments. So this is going to go up from 0 to 1, stay there, and then go back down. So it's got an attack time, a sustain time, and a release time, and all the segments are linear. And now envelopes have a done action too as well. We've had a problem like this on the homework before, where we had like a filter envelope and an amplitude envelope, and they both have done actions, or should they, is the question. Because we're conceptualizing this SynthDef as just playing a short section of the sound, it doesn't really make sense to ever say done action 2 for the play buff, because it's the amplitude envelope that is going to determine when the sound is, over, like completely done. So I think we could even just we could even get rid of this, or at the very least, reset this to 0, so that the done action of the play buff is 0. So if play buff gets to the end, it won't do anything. It may also make sense to loop it by default. So this just starts anywhere and just goes through. But the envelope, which we're going to apply right here, sig equals sig times env, that's going to be considerably shorter. We also need to add these. We'll say a millisecond. Let's do a centisecond. Tenth of a second sustain, and then another, rel equals, right? So that looks pretty good. I think we can hard code this done action 2 in here, because since we're applying an envelope, which is going to be fairly short, that's our sound, right? The envelope determines the start and end of the sound. So that should have done action 2, and there's no harm keeping this here. But, for example, if the start position is such that we're at like 99% of the way through the buffer, so that there's only like a millisecond until the end of the file, if this has done action 2, play buff is going to kill that synth very quickly, because it's like, I'm at the end, I'm out of here. And the envelope, if it's like a tenth of a second, doesn't even have enough time to finish. So that's why I think it makes sense to just loop and say done action 0. So if the play buff gets to the end, it's just this continuous process that never ends. And we're going to be specifying start position to tell it what part of the file we want to play. And this is just 0.12 seconds altogether. Right? The sum of all the segments is just 12 centiseconds. So pretty short. Let's close this. And that's what we want to see. So now we can say, I'm going to copy my work from up here. Take this one, I guess. And drop that here. So PB2env is the name of that SynthDef. And we are going to say rate will leave you at 0, MIDI ratio. And we don't even need to say loop, because it's 1 by default. I mean, rate is also 1 by default. So let's play it.
What?
Yeah, that's the first 0.12 seconds of the file. You almost get all of the W in WoW.
What?
We can say, give me 20% of the way through. There's sound editing.
It
gets easier. Should be an E somewhere around here. There's an E. Easier. Beep, beep, beep. Yeah, so now we're doing some fun stuff here. Why not drop this into a routine and give ourselves a little rhythmic pattern generator kind of thing. So we want a loop. And whenever you make loop, you make a wait time. Let's say wait 0.2. And that is all we need, I think. Yeah, okay, that sounds kind of bad. But let's say attack a millisecond, sustain, no sustain, and release will make that even shorter than a tenth of a second. So that should sound like this. Yeah, I don't know why it's hiccuping. That might just because I'm also streaming and there's just a lot of stuff going on my computer right now. So good question. Let me do it after 350, because that is going to take at least 5 minutes, probably more. But if you want to stick around, I'll do TGrains. We're kind of doing a similar thing here. So now we're always starting 55% of the way through the file. So can you wait outside of the loop? Yes, you can, but you really have to wait inside the loop too, because if this wait, I mean, sort of, if this was a finite loop, if it was 5.do or something, then if it did this 5 times, then you could say 1.wait or wait 1 or whatever. and then you could do another 5.do or something. But yeah, as long as you're inside of a routine, wait is a valid thing. And if you're playing a routine, you can wait wherever you like. Doesn't have to be inside the loop, just has to be inside the routine. But it is really essential that we wait inside of this loop, because if we don't, we get stuck there and SuperCollider crashes. Okay, so if we don't want to always start at this exact sample, you can give yourself a range. That's not the right spelling. So we'll say somewhere between 50% and 60%. And we will drop the wait time even more, and that sounds like this. That doesn't seem right. Oh, semicolon. Haha. Yeah, interesting that didn't throw an error. We need a comma there, because if we put a semicolon, it says, okay, I'm done. You know, or I'm not really, I think this is what we need to do here. Yeah, okay, so that's working. Right, we can make, so we're basically kind of doing granular synthesis here, in a way, right? We make a routine, and it is, it's looping and just picking a new grain each time, right? Yeah, it's very Polanski. So yeah, we can make this a little longer, make this a little longer, so they're kind of turn the amplitude down a bit, and we can make like a kind of a grainy, long grain texture. Maybe give ourselves a wider range to work with. Now we can also randomize the wait time, like this. Yeah, and I think I was trying to play around with something a little bit earlier. Now we can I think I want to try is like let's go ahead and make let's mess with rate a little bit more. That's what I was doing. So MIDI ratio, and let's go back to a rhythmic thing, because rhythm is fun. And bring this back to a short value. I'm just trying to tweak these values a little bit, do something fun. Yeah, so if this doesn't sound regular for you, I apologize. I think it works. Routines happen to run nice and smooth when I'm not streaming, but if you try this on your own, it should be a nice, clean 10 grains per second. What I wanted to do was, let's just make a variable here called semitones. We'll start it at like -24. Like if we could bypass this for a second and randomize the rate, we'll say -24 to 0 dot MIDI ratio. So it's going to be some transposition between no transposition and down 2 octaves. Yeah, as if we weren't already imitating Polanski enough. But, yeah, but that sounded pretty nice. Now, if we wanted to do like a sequence, right? Here we can do a little counter, right? So we'll start at -24. By the way, I think you need parentheses around the 24. If you do it this way, yeah, it gets confused. It gets confused by the equals minus, because so many of these operators are overloaded and used for multiple things. So you got to do parentheses around negative numbers in variable and argument declarations. I think you can also put a space. Can you put a space there? Is that going to work? Yeah, space also works. So whatever your flavor, doesn't really matter. And what we're going to say is at the end of playing a synth, we'll say semi equals semi plus 1. And if we leave it there, we're asking for trouble, because it's just going to keep going up. Oh, whoops. We got to plug it in here, don't we? Okay, we're going to command period that before it gets out of control, chipmunk style. So what we want to do here is say, okay, let's do a check here. If semi is greater than 0, then reset it. Like that. Yeah. And there's so many things. I mean, just everything is, maybe you don't want to reset it to negative 24. Maybe you want to reset it to some value between, I don't know, negative 12 and negative 1 or 2. This way it might get stuck sort of near zero transposition for a while. And you can do like kind of a rhythmic thing here by just saying choose from these 3 values here. Okay, maybe it sounds better like this. Well, it sounds all clunky and non-rhythmic to me. I hope somehow it's working over stream, but I have a feeling it's not, which is kind of annoying. But if you copy this code and try it yourself, it should be lots of fun. And gosh, yeah, I think that's it. I also wanted to talk about buff read, which I guess we don't really have time for, but I'm gonna do it in a 2-second introduction. So buff read is an alternative to play buff. It's a unit generator, and we're just gonna make the quickest, dirtiest sound function here. Like play buff, it needs the number of channels, it needs a buff num, and then it needs something called phase, which is an audio rate signal. How does it define it here? An audio rate modulatable index into the buffer. So basically, it should be a signal that spits out values somewhere between 0 and the number of frames in the buffer, -1, because index starts counting at 0. So the simplest way to do it here is an audio rate line that starts at 0 and goes to the number of frames in the buffer. Technically, -1 is correct here. And then the duration should be the duration of the sound file. So we can get all this information here, close that off and play it. And let's do wow, because speech is easier to deal with, or easier to understand what's going on. So
Wow, sound editing just gets easier and easier.
And what I forgot to do is put a done action 2 in the line. It got to the end and it said, okay, I'm done. I'm not going to do anything because done action is 0. So it would be more appropriate to do this.
Wow, sound editing just gets easier and easier.
And so from here, it doesn't have to be line, right? You could do like X line. And X line needs both of its min and max, its start and end to be the same sign. So we should actually start one sample in. Yeah, so that's an exponential line reading through the file. Real slow at first, basically not moving, and then and we could also do if we want to play it backwards, that's pretty easy. We just swap the start and end. Right? So start at the last frame and go to the first frame.
Wow.
And then it doesn't have to be a line or an X line. It could be any audio rate signal. So coming back full circle to the idea of range, we want this to be, I guess, pretty slow. I'm just going to estimate a value here. Well, actually, it's like 11 seconds. So we need this to be, 1 over the duration is an appropriate frequency because period and frequency are inversely related. And we set the range to be 0 to wow.num frames -1. And this will sinusoidally zip forward and backwards through the file, I think.
Easier. Wow. Wow. Easier.
Yeah, slow it down a little bit.
It's easier.
And easier. Wow. Wow.
Sound editing just gets easier.
And easier.
Yeah, very, very tape. Right? You've got 2 reels of tape and you're sort of zipping it across slow and fast, and then you slam on the brakes and roll the tape back the other way. Cool. So that is buff read in a nutshell. From here, I would loosely expect everyone to be able to put together a basic SynthDef, with all the arguments and everything using buff read instead of play buff. So definitely check it out and maybe try a bunch of different unit generators. Just remember they need to range across all or part of the buffer, and it's a value in frames, so it's quite high, right? This value is, you know, something you'd never want to play through your speakers. Like, amplitude is way too high. Cool. That is it. So I guess I'll see everyone next week. And I don't know if Eric, are you still there? I can do a quick TGrains demo if you're interested. But otherwise, call it a day. Cool. All right, thanks. So if you want to see some TGrains stuff, you can stick around. But if not, keep an eye out for a homework. And those of you who are departing, I'll see you next week. So let's talk TGrains for a second. So TGrains is a granulator. And I don't use it too often, but basically you give it the number of channels of output you want. So we'll make this a stereo granulator. So trigger, this is a signal which whenever the signal undergoes a non-positive to positive transition, that's considered a trigger, and we get a grain. TGrains produces a grain. So I'm going to say impulse.ar2. So 2 triggers per second. Buff num, I'm pretty sure this has to be a mono buffer. So I'm going to use num. And rate. Here's where I probably should look at the help file. This is probably, yeah. Okay, so this is the same thing as play buff. So if we say 1, or probably we should say buff rate scale for normal rate. Then center position. This is position. Now, I don't know if this is samples or if this is rate buff doer. Oh, I think it's in seconds. Is it in seconds? Center position. Yeah. Oh, I'm just blind. Okay, so num dot duration times 0.55. So this should be. Oh, I'm treating it like it's the WoW sound file, but we'll just drop somewhere like right halfway through. That's the center position. And what's next? Duration of the grain. We'll make this 8 centiseconds. So a pan position, 0 would be centered, -1 would be all the way left, 1 would be all the way right, and amp, I guess by default it's 0.1. That's sort of interesting. Kind of unusual for a UGen. We'll keep it there. And interpolation 4. That's how it's going to resample if the playback rate is not 1. So I think this should make sound. Let's see if it does. Yeah, it does. We'll make 8 grains per second. And instead of always starting halfway through, we can say LF. Oh, yeah, mouse X, sure. We'll do mouse X for this. 1 to 50, no, 1 to 100 exponentially. And we will do mouse Y for center position. So this goes from 0 to num dot duration. Let's try it. Uh-oh. Did I just crash the server? Why did that fail? Why did that fail? No, I can't use AR for that. That surely wasn't it. Oh, I know why. Because I can't do an exponential. I have to do like. Oh, let's make it linear. We're going through a sound file. There's no reason to make that exponential. This should work. All right, we don't need it to be that quiet, do we?
1, 1, 0. 1, 0.
I want this to be AR, actually. Are there other input options? Yeah, as far as UGens go, there's not that many. There's mouse X, mouse Y, and mouse button. So you can get the real-time mouse pointer, X and Y coordinates, and you can also get a 0 or 1 based on whether the mouse is being clicked. That's kind of all there is for UGens. Those are like conveniences for just testing things out. So that's about all there is. But I mean, once we get into like graphical user interfaces, you can use the buttons on the keyboard and all sorts of things. You can do MIDI and OSC. But as far as UGens go, those are the main three options, I think. So, Eric, does that loosely explain kind of how TGrains works? Do you think you get a sense of what can be done from here, or like how you would do X or Y, or how you'd take this code and go in a direction? Yeah, I like it too. Fun stuff. Cool. Okay, I think that's going to be yeah, you can. Yeah, TGrains allows. Yep. I mean, it's a granular time. It's a granulator. So it's pretty easy to, yeah, just sort of separate pitch and time. Like if we set this to, I don't know, 50 and made it like dust, and then we used mouse X instead for this. We say let's go down 12, up 12, linear MIDI ratio. Actually, I kind of like impulse better. Yeah, let's make more. 60. Yeah, so we're scrubbing through the sound file vertically, and we're changing the pitch of the grains horizontally. And you can tweak this, like if you made this dust with like really dense grains, like 300 or 400 or something per second, that's maybe a little overkill, but like tons of grains so that they overlap randomly, and then maybe or make the grain duration larger, not too large, not like a second or 2 seconds, but that would probably give you a half decent time stretcher pitch shifter. It's always going to have some degree of granular artifacts in there, but yep. Yeah, it is very creepy doll. Like doll's head rotating around 360 degrees. Well, I actually don't think I could help Brandon too much because I've never used Emacs or any sort of alternative editor for SuperCollider code, but if I wanted to learn more, I'd probably kind of Google around or maybe ask something on the SC Synth, what do you call it? Not the listserv, but the forum, I bet there's some sort of obvious tutorial out there. I'm sure the other people have done it. I think you just got to get pointed in the right direction. Unfortunately, I am not the person to do that. Whew. Okay. So I'm going to wrap it up. You're welcome. Hope you find what you're looking for. My opinion on pure data. Well, I mean, it's a graphical patching language, which I find to be fairly tedious to use. Hey, Amit, thanks for stopping in. Yeah, PD and Max, they're not my favorites just because I find it's just a lot of mousing around and clicking on little pixels and dragging. And I just find that is just tiresome on the wrist more so than typing. Typing isn't great either, but it's free and it's cross-platform, which is fun. So it's pretty easy to download and get cooking. I feel like the vanilla PD library is very vanilla. It's very pared down. Like you have to do a lot of complex stuff by building it yourself. But I like PD because it's free, and I'm always into the free stuff. Oh yeah, PD. Oh, that's like their version of PD for their laptop orchestra, right? Yeah. Anyway, this has been fun. Next week we are gonna get into effects. So like delays, reverbs, and that is going to necessitate a discussion about groups and buses and inputs and outputs. And we're actually going to start passing signal from synth to synth with ins and outs and talk about the architecture of the server a little bit. It's going to be a cool class, I think. Always really nice to get some complex signal flow going, so it's not just a single SynthDef that does everything, but you actually have multiple SynthDefs kind of talking with each other. All right, so thanks everybody for stopping by. I hope you enjoyed the class. Hope you have some fun messing with buffers and playing things backwards and making creepy doll sounds. Yeah, enjoy. So once again, thank you. See you all next week.